Hi again. So we're going to talk about some exponents and division problems, so just a few practice problems to get you started on your activity today. So again, we're over here on exponents and division worksheet from the CUDA software. Number 2, we're dividing like bases. We have 3 divided by 3 cubed. And just so that I don't get myself mixed up, I'm going to write a little 1 there so that I don't forget it. So when I divide like bases, I'm going to keep the base and I'm going to subtract the exponents. So 1 minus 3 is negative 2. 1 minus 3 is negative 2. And I don't want to leave it this way. It's not really proper in math to leave an exponent as a negative. So remember, when we have negative exponents, we take the reciprocal of the base and we change the exponent to a positive value. So it goes from a negative 2 to a positive 2, and we can rewrite it as 1 over 9. If we take a look at number 4, again we are dividing like bases, so we are going to keep the base and subtract the exponent. So 4 minus 2 is 2, and 2 squared is 4. So we have our simplified answers here. Onward to number 6. 7 over 4 I cannot simplify. However, I can work with k squared over k cubed. So I'm going to write my fraction bar. I'm going to put my 7 and my 4 in. Now k squared over k cubed, I'm going to keep the base and I'm going to subtract the exponent. So 2 minus 3 is a negative 1. And because this is a negative exponent, I cannot leave it the way that it is. So I'm going to take the reciprocal of the base. So what happens is that k is going to go from the numerator to the denominator, and this exponent of a negative 1 is going to change to a positive 1. And so we end up with 7 over 4k. If we look at number 14, we have 14 divided by 6, so I can simplify because 2 goes into both of these numbers. So I'm going to rewrite my fraction bar. 2 goes into 14 7 times, 2 goes into 6 3 times. And now I'm going to work with the x to the 4th over x to the 5th power. So when I divide like bases, I'm going to keep the base and I'm going to subtract the exponent. So 4 minus 5 is a negative 1. And now I have y to the 7th over y to the 4th. I'm going to keep the base. I'm going to subtract the exponent. So 7 minus 4 is 3. So I am not done with this problem yet. This guy right here has a negative exponent. So I need to take the reciprocal of that base. So what that means is that x is going to go from the numerator down to the denominator with a positive exponent of 1, and the y cubed is going to stay where it is on the top. So we're going to rewrite this as 7y cubed over 3x, and that's all the way simplified. And last one we're going to check out here is number 20. 16 times yx to the 4th divided by 9x to the 8th y squared. There is not any number that divides into the 16 and the 9 evenly, so we're going to leave the 16 and the 9 the way that they are. However, now I'm looking at x to the 4th divided by x to the 8th. So 4 minus 8 is negative 4. And over here I have y divided by y squared. So that y has an exponent of 1 even though we don't see it. 1 minus 2 is negative 1. So to fully simplify here, this has a negative exponent, this has a negative exponent. We're going to take the reciprocal of these bases, so they're going to go from top to bottom, both of them. and the exponents are going to go with them, and they're going to be changed to a positive. And so we end up with 16 divided by 9x to the fourth times y, and this one is all the way simplified. So just a little bit more about negative exponents that I'll do off to the side here. If we had something like x to the 5th power divided by x to the 8th power, I know that I can do this two ways, okay? I can use my laws of exponents for the division rule and think about, okay, well, this is the same as x to the 5 minus 8, which is the same as x to the negative 3rd power. And I know that when it's negative, I have to take the reciprocal of the base and change the exponent to a positive. But if I wanted, I could think about this a little bit differently. So here's a little shortcut. When we're dividing like bases, we are constantly thinking about what to do with the exponents. So we're going to subtract the exponents. Only I'm going to change this a little bit. I'm going to just think about what's the difference between 5 and 8. And I know that the difference between 5 and 8 is 3, okay? The 8 is higher. So if I think about maybe calling this the more rule, okay? 8 is more than 5, and so that is where my variable and the exponent are going to go. I know that the difference between 5 and 8 is 3. I know this one is higher, so I'm going to be thinking about this as being 1 over x cubed. It's kind of like a little bit of a shortcut. You can still do it this way. You can think about it as a shortcut. As another example, if we had something like a to the 5th, b to the 4th, divided by a to the 9th power, b to the 2nd power. If I treat the a's and the b's separately, I know that the difference between 5 and 9 is 4. That 9 is more than 5. So if I'm thinking about my shortcut, a to the 4th would go down on the bottom on the denominator. When I divide like bases, I keep the base, subtract the exponents. The difference between 4 and 2 is 2. The 4 is more, so following my little more rule shortcut, the difference is going to go on the top. And I end up with b squared over a to the 4th. If I were doing this out differently, I had a to the 5 minus 9 and b to the 4 minus 2, and that would become a to the negative 4th b squared. And I know that I cannot leave the negative in the exponent, and so this is going to come down to the bottom where it's positive. So just notice the answers here are the same, it's just using a slightly different process. Okay, so that's it for now. Thanks, guys.